All right, guys and gals, in our previous lesson, we were looking at the laws of exponents, specifically the first law dealing with products of powers. Today, we're going to look at quotients. We're going to look at dividing. So let's try a few, just see what we can do, and then we'll talk about that second law and what it actually means and how we can use it. So let's start off with this first one. Remember, we said exponents are comprised of two parts. We've got the base, so in this case of 2, and the power, in this case of 5. So that tells me that I want that base of 2, 1, 2, 3, 4, a little more, 5. All right, so I want 5 of them. Here in the denominator, we've got 2 to the power of 3. So again, same base, different exponent, and that's okay, but the same base, and that's what we're looking for, but it's going to be 3 different goes. So let's write that out. 1, 2, 3. Now, one way to work this problem out to simplify it is to go ahead and multiply all these 2's, go ahead and multiply all those 2's, get a couple of answers here, numerator and denominator, and then simplify or divide out from there. And that's one way, and it works fine. Problem is that's a lot of multiplication to do than having to divide. But let's try something else. Since we're multiplying top and bottom, watch what we can do. I'm going to cover up everything else except those first 2's. 2 divided by 2, because notice these are multiplied, so that means these are factors. If I have 2 numbers with common factors, I can simplify them top to bottom in a fraction. So for example, if I had something like, say, 9 thirds, okay, I can divide a 3 out of those because this is consisting of 2 3's. This, of course, had 1 3. We can divide that out and simplify it to just 3 over 1. Well, I can do the same thing here. I can go ahead and divide 2 by 2 and end up with just a 1 that's being multiplied here. All right, well, I can try that trick again. I still have a 2 over 2, common factors there. All right, divide it out. We get a 1. We've got a few more 2's there that we can deal with. All right, so divide it out, and we get a 1. So I've got 1 multiplied by 1, multiplied by 1, multiplied by 2, multiplied by 2. Well, if I rewrite that, that's 1 times 1 times 1. Well, multiplying by 1 is silly, so I'm just going to ignore that. I've got 2 times 2. Well, that's just 2 to the second power. Interesting. All right, let's look at that again. I went from 2 to the 5th and 2 to the 3rd down to 2 to the 2nd. What could I have done to maybe have sped this process up, not to have spent all the time in this sort of work, which seems sort of silly. I'm just making 1's after all. All right, let's try another one. We'll see what we can work out here. This time I notice I'm working with exponents that have a base that is a variable, so we can work with those just like we did here. But I also notice I've got some coefficients here. I've got 12 and 8. And remember, since we're multiplying 12, and then we've got 8 here, we can treat those just like a normal fraction, 12 8. So we could simplify or do whatever it is that we would normally do. For the x's, I have to extend that a little bit. I've got 1, 2, 3, 4, 5, 6 x's. Oh, good Lord, the bottom's going to be even more. 1, 2, 3, 4, 5, 6, 7, 8. Goodness. Well, we can pull the same trick that we did up here with the x's. So let's start there. I've got these x's that cancel, so that's a 1. These x's that 1. You get the idea. Notice all of these x's are being reduced. We can factor them out. All right, I can divide x by x, and so on. Here, I can simplify just like I would with a normal fraction. So if I have 8 and 12, both of those are divisible by 4. So I can divide 12 by 4 and get 3. I can divide 8 by 4 and get 2. So my final answer, let's see what we get. 3 stays up top because notice I've got 3 times 1 times 1 times 1 times 1. You get the idea. 3 times all those 1's is just 3. 2 times all these 1's is just 2. And then I've got x squared. So again, not dealing with coefficients because we already knew how to simplify a typical numeric fraction. What can we do with these powers? For example, how can I go from 5 and 3 down to 2? All right. Or how can I go from 6 over 8 down here to a 2 in the bottom? And remember, if we were to write that out, we could write it as x to the 2nd, right? If we were to write it outside of a fraction, and then if we were to rewrite it, it means that that x squared would go to the bottom. Right? So technically, this is a negative exponent that's been rewritten. Interesting. All right, well, let's take a look at the quotient law, and then we'll see why those worked out the way they did. Law 2, quotient of powers. When you divide powers of the same base, you can simplify the expression by, again, keeping the base. So again, don't ever get rid of the base. And then we subtract the exponents. All right, we'll take a look. If I take 5 and subtract 3, sure enough, I get 2. And isn't that basically what I did? I had 5 2's, 3 2's, and then basically just subtracted those out and just took them off. And then look down here. I had 6 x's and 8 x's, and by the time I'm done subtracting, I've got 2 left over, but 2 in the bottom, a negative 2, telling me, hey, move it down to the denominator. So let's try that. Let's see if it'll work. If I subtract here 5 and 8, so I've got 2. Remember, we keep the base. Don't try to simplify. We're not simplifying the 2's. The base stays the same. So if we keep the base and take 5 and subtract 8, just like we did here, 6 and subtract 8, we should get 2 to the power of negative 3. Well, remember, we don't like negative exponents. Leaving them like that is not kosher. We don't do that. So what we'll need to do is rewrite it. We'll put it into a denominator, so 2 to the third. Remember, when we drop it down, negative goes away. But we do need something on top, all right? And notice here, we ended up with 1's. And the 1 is what allowed us ultimately to help us simplify. But notice here, those 1's ended up on top due to our factoring out, right? That multiplication process that we ultimately went through. So there is technically a 1 here in order to allow this to stay a fraction. So 1 over 2 to the third. All right, cool. Well, let's try another one. Notice this has some multiplication in it from yesterday. From our lesson, not from yesterday necessarily, but from a few days ago. So let's try it. So I've got 3 to the fourth and 3 to the seventh. Since that's in the numerator together, I want to do that first. So 3 to the fourth. And remember, the 4 and the 7 will add together. All right, so we'll do that here in just a second. We'll keep this 3 to the sixth. Oh, 3 to the sixth. Look at me. I'm rewriting it backwards. There we go. 3 to the sixth, not 6 to the third. Very different. All right, well, let's see. We've got 4 add 7, so that's 11. So 3 to the 11th over 3 to the 6th. And it looks like, again, our second law of exponents can take over. I can simply keep the base and take 11, subtract 6, and end up with 3 to the 5th. Cool. Now, a shorter way to do that problem, I'm sure you're looking at it going, wow, that's a lot of work. A shorter way to do that problem would be recognize we have a common base throughout. All right, so 3 stays. I'm going to take 4, add 7, so 4, add 7, and then immediately subtract the 6. Well, 4 add 7 is 11, subtract 6 is 5. Cool. So there's a quicker way to do that. But again, I'm showing you those steps so that you can see my thought process. All right, let's try this one. Notice we've got some coefficients going on there, so we can simplify those. So let's do that up front. If I have 6 over 3, well, I could take 6 and divide it by 3 and get 2. And 2, since it has an exponent of 1, goes up top. Remember, positive exponents go on the top, negative exponents go on the bottom. So let's do it that way. So 2 goes up here in the numerator, right, the top part of our fraction. Let's see where everything else ends up. I've got x to the fourth and x to the second. So I could write it as x to the fourth, subtract 2. I also have y's, right? So I'm going to put this over 1 for now. We've got y to the fifth, subtract 9. All right, well, let's rewrite it. The 2 is going to stay. We already knew that. 4 subtract 2 for my x's is a positive 2, so positive 2 stays up top. 5 subtract 9 is a negative 4. Remember, negative exponents go down to the bottom and we drop the negative. So y to the fourth. Cool. So again, it looks really ugly, but by the time we're done, it's really not that bad. All right, let's try one more here. Lots of different things. Remember, we can only deal with like bases. So for example, this 9 in the denominator can't mess with that 7 in the numerator, only with like bases. So let's rewrite. I've got 2 over 14. Well, we could simplify that to 1 over 7. Again, we can divide both of those by 2. Ultimately, multiplying by this 1 is sort of silly, but we'll leave it there for now just to show that we did simplify. I've got x to the 9th, subtract 9. And then I've got m to the 7th, subtract 2. Right? Well, let's rewrite. We said that 1 really doesn't make sense. So for the time being, I'm going to just take that 1 out. The 7 will remain. I'll write that down here in just a second. Notice I've got x to the 9th, and then, of course, x to the 9th. So 9 subtract 9 is 0. Well, anything to the power of 0 is 1, provided that anything isn't a 0 itself. So cool. I've got 1 times 1, basically. Well, 1 times 1 is still 1, so I'm not going to write that 1. And then we've got m to the 7th, and then m to the 2nd. So 7 subtract 2 is 5. So up top, since that's positive, m to the 5th, and then down here, the 7 will remain. Cool. And notice the x is gone. We would end up with x to the power of 0, as we said. And so long as x isn't 0, we know our result here will be a 1. Cool. All right. Well, on the back here, we've got a series of example problems that we're going to work through here real fast. That way you've got plenty of examples to look at and mirror. Again, I'm not going to do a lot of explaining on these. I'm just simply going to work them out. So that way, as you see these kinds of problems, you'll know what to do. So let's start up top. We've got a multiplication issue, a common base. Remember, this does have an exponent of 1, even though it's not written. 1 add 4. So keep the base, add those together, 8 to the 5th. All right. Again, same base. We're multiplying, so we'll add, in this case, 6 to the 4th. All right. Notice we've got some coefficients here. So 2 times 2 is 4. And then I've got n to the 2nd, n to the 4th. We can add that 2 and 4 n to the 6th. All right. Notice we've got 3 different coefficients here. Goodness gracious. So we'll take 8 times 8, which is 64. And then we'll take that 64 and multiply it by 3, and that is 192. Cool. Notice we have b, b, and b, so we've got 3 b's there. B to the 2nd, so there's 2 of them technically. B to the 1st, and then b to the 3rd. So we can add 2 to 1, that's 3. 3 added to 3 is 6. So b to the 6th power. Cool. I'll simplify. Let's try number 5. I've got 5 and 8, so we can multiply those together and get 40. I've got r to the negative 1st, r to the 3rd. If we add those together, we get r to the 2nd. Again, negative 1 add 3 is 2. Right? I've got 3 and 3, so 3 times 3 is 9. Coefficients we multiply just as we would normally. N to the 3rd, n to the 3rd, so a common base. Keep that base. 3 and 3 make 6. Remember, we're adding exponents, not multiplying them. All right, well, let's try some division problems because that's our main focus today. Now we've done a little review there with multiplication. Notice this is 3 to the 1st power, even though we don't write it, we assume it's there. So we really have a common base. Remember, do not simplify bases. Keep those bases as they are. So we have 3 to the 1st, subtract 2. That's another way of saying 3 to the negative 1st, which we don't write. We need to drop that 3 to the denominator. We don't write powers of 1, so we'll just drop it. But we will make a numerator of 1. That way we have our fractions. In this case, 1/3. All right, let's try the next one. We'll take 4 and subtract the 2. Again, we're dividing powers with common bases. So we end up with 7 to the 2nd. All right, let's try it here. I've got 4 over 6. I can simplify that fraction to 2/3. And then ultimately, negative 3 subtract 3. So x to the negative 3rd subtract 3 more. Well, that means negative 3 subtract 3 more is a negative 6, which means it goes to the denominator. So the 2 stays up top. The 3 stays where it was, but the x is going to drop down here. And since we'd end up with a negative 6, we're going to write it as positive 6 now that we've moved it down. Remember, the negative just says move it to the denominator. Once it's there, we don't need the negative anymore. All right, we've got 8 over 2. Those are our coefficients, so we can divide those as normal. So 8 divided by 2 is 4. We'll write that up top here in the numerator. Here in the denominator, I'll have a 1 just as a placeholder. And then we've got n to the 2nd. And then, of course, we'll subtract a negative 4. All right, well, 2 subtract negative 4 is a fancy way of saying 6. So I'll end up with 4 n to the 6th power over 1. Well, a denominator of 1 really doesn't make sense. So I'm going to rewrite this as 4 multiplied by n to the power of 6. Remember, we can add a line, change a sign. So 2 add 4, we get 6. Looks good. All right, let's move that up a little bit. For 11, 5 over 2 doesn't simplify, unfortunately. So we're just going to have to keep that as is 5 over 2. All right, well, let's look at the u's. We've got u to the second, and then, of course, another u to the second, so we'll subtract. And then we've got v to the third, and again, subtracting another third there. So again, the 5 and the 2 don't change. We'll go ahead and write those in, 5 and 2. U, and then we'll take 2 subtract 2 is 0. So long as u isn't also a 0, anything to the 0 power is 1. Well, I'm not going to write multiply by 1. That's silly. V works the same way. I've got 3 subtract 3, which is 0. V to the 0 power, assuming v itself is not a 0, should equal 1. So that's 5 times 1 times 1. Well, that's just 5. So I'm not going to rewrite that any differently. We'll just leave it as 5 over 2. If you wanted to, we could rewrite that, make it into a mixed number. 2 goes into 5 twice with 1 left over. So if you wanted to write it as 2.5, technically, you'd be very much within your rights to do so. I would accept either answer in this case. Some would prefer that, however. All right, let's see where we're going. Number 12. 8 divided by 4 is simply 2. So let's write that down up here in the numerator. We'll put 1 as a placeholder for now. If we need to drop anything down there, we can. We've got 2 subtract. There isn't an exponent here, so we'll put a 1. So u to the first. So we got 2 subtract 1. And then v's, we got v to the fourth subtract 3. So let's see here. The 2 stays. 2 subtract 1 is just 1. So I'm going to write it as just u, not u to the first. Again, we don't write powers of 1. And then 4 subtract 3 is also 1. Again, I'm not going to write a power of 1. That's silly. Since we don't have anything in the denominator other than 1 dividing by 1, still silly. So we'll just write it as 2uv. All right, we're almost done. 3 over 7 doesn't simplify. So let's just write it down. 3 over 7. And then I've got x to the first. Because again, nothing there. We assume it's a 1. Subtract a negative 4. All right. Well, 1 subtract negative 4. Again, we can add a line, change a sign. And that's 1 add 4. So that's 5. So let's rewrite it. 3 multiplied by x to the fifth over 7. And again, that's as far as we can go. We can't simplify further. Last one. 8 over 3 doesn't simplify, so we'll just hold on to the 8 and the 3. If that was, say, 8 to the second or 8 to the fourth, then yeah, we go ahead and simplify. But since it's a third, we'll just hold on to it. I've got v to the first, subtract 4. Well, that would give us a negative 3 for our exponent to go with v there, so we'll need to move it. So the 8 stays up top. The 3 hasn't moved. We'll keep it there. And this would be v to the negative third. 1 subtract 4 is negative 3. We'll drop it down. V to the third. And remember, when we move a negative exponent down, we drop that negative off it. We don't need it anymore. All right. Well, there are all of those example problems worked out. So now you've got 14 in your possession, all worked, all work correctly. Gives you good opportunities as we go through our work in class today to figure out what's going on. Use these as reference points for maybe problems that you're unsure about. Again, if you have any questions or concerns, if something on this was unclear, write yourself a note right now. So that way when I see you in class and ask, hey, what issues did you have? You'll remember what you were concerned about, maybe what you were unclear about, and then we can work on it together. All right. Have a good day, folks. We'll see you in class.